Hello everyone and welcome back. Today I'll be talking about gravimetric and volumetric analysis. I will also show you how to calculate percentage by mass of a certain species in my sample. I'll provide a link in the description of the video where you can find the slides included in this video. So first, what is gravimetric analysis? Gravimetric analysis is a type of quantitative analysis in which the amount of the species of the material is determined by converging one of the species into a product. This product I can isolate completely and weigh. Precipitation reactions are usually used in gravimetric analysis. I have to know one thing. When I am doing the gravimetric analysis, I cannot establish a full identification of a known sample. Instead, I can give percent by mass to one of the species, the anion or the cation. Example to that, if we look here, if I have sample of sodium sulfate and a sample of lead nitrate, if I want to know the percent by mass of the lead nitrate, I can react the lead nitrate with the sodium sulfate. This will give me a precipitate. This precipitate is a lead sulfate. I can isolate this precipitate and wait after dry and know the percent by mass of the lead in my product, and from that I can compare it to the percent by mass of my initial reactant components. In gravimetric analysis, we usually follow certain steps. The first step, I dissolve my sample that I need to identify the composition of one of its species in water. Then I reacted with another substance that I know that I will get a precipitate. I collect this precipitate, I dry it and weigh it. The known mass of and the chemical formula of my precipitate, I can calculate the percent by mass of the needed species in the product, and from knowing the mass of the original sample I can get the percent composition of my species in the original sample. Let's take an example. If I have 0.6 grams of ionic compound containing chloride ions and unknown metal is dissolved in water and treated with excess silver nitrate. If I have a product which is around 1 gram of silver chloride, what is the percent by mass of chloride ions in the original compound? Let's write first the reaction of this example. If I have a metal with chloride ions, I can just react it with silver nitrate. That will give me silver chloride, which is a precipitate. If I collected this precipitate, I found out it's around 1 gram. And I know the original weight of my sample, which is 0.5662 grams. Can I find out the percent by mass of the chloride ions in this sample? So to be able to calculate that, first I need to know the molar mass silver chloride, and it is equal to 107 plus 107 the atomic mass of silver and the 35.5 the atomic mass of chloride. This would be equal 144.3 grams. Now I can calculate the percent of chloride ions, the theoretical percent of chloride ions in the silver chloride, which would be equal to 35.5 the atomic mass of chloride ions divided by the total mass of the silver chloride multiplied by 100. This is equal to 24.7%. Now I know the percent by mass theoretically. If I compare it to the calculated one or the obtained one, so the mass of chloride in AgCl would be equal to the weight of the sample that I collected multiplied by the percent of the chloride ion in my sample divided by 100. From that I can find that it is equal to 0.2690 grams. Now I know the mass of chloride ions in silver chloride, and I know my original weight of the sample. So if I divide the mass of my chloride ions divided by the total mass of my sample, I can get the percent by mass of chloride ions. So percent by mass of chloride ions would be equal to the mass of the chloride ions in the silver chloride divided by the total mass of my original sample multiplied by 100. From that I can find out it is 47.51%. So you could see here that from knowing the weight of the precipitate, I can just calculate percent by mass of my chloride ions in the original sample. Let's take another example. A 1 liter sample of polluted water was analyzed for the presence of lead ions by adding an excess amount of sodium sulfate. The mass of the lead sulfate that precipitated was around 229.8 milligrams. What is the mass of the lead in liter of the water? So first I need to calculate the molar mass of lead sulfate, which would be equal to the atomic mass of lead plus the atomic mass of sulfur plus the atomic mass of 4 oxygen atoms, which would be equal to 303.2 grams. So from that I can calculate the percent of the lead in lead sulfate, which would be equal to the atomic mass of lead divided by the total molar mass of lead sulfate, and I multiplied by 100 to get the percentage. That would be equal to 68.32%. From that I can calculate the percent or the amount of lead in the sample. The amount of lead would be equal to, in sample, would be equal to the grams that precipitated multiplied by the percentage of the lead in the lead sulfate. That would be equal to 157 milligram lead. This means I have in 1 liter sample around 157 milligrams of lead ion. Now moving to volumetric analysis. Volumetric analysis is a method of analysis that we use to measure the concentration of certain material of unknown concentration. We usually use what is called titration. In titration we use a burette which will contain what we call a standard solution, and this standard solution I will add gradually to a measuring flask. In this measuring flask I will have a certain amount of unknown sample. When I gradually add my known concentration to the unknown concentration in the presence of indicator, I will have this equivalent point. This equivalent point will be the point at which my standard solution will be completely reacted with the material that with unknown concentration. There are a few types of the titration. There is what we call redox titration. In redox titration, we will use an oxidizing reagent will be added as a reducing agent. This will involve the transfer of electrons where equivalent point is reached when reacting agent is completely oxidized by my oxidized reagent. Examples for that, we have some common oxidizing agents such as potassium permanganate and potassium dichromate. the transfer of color between purple and light pink will give me the indication of the end point of the titration. Another titration is the acid-base titration. In acid-base titration, a solution of accurately known concentration that we will use, as we said, the standard solution that will add gradually to another solution. My reaction will stop, or the equivalent point will be reached when the concentration of the material, unknown material, is completely equivalent to the amount that I add from my pirate. In those titration, we usually use indicators. These indicators will give me an transfer point from a color to another color that will give me indication to the end of my reaction. Example to that, the titration of sodium hydroxide with sulfuric acid. If I don't know the concentration of my sulfuric acid, I can just titrate it against the sodium hydroxide. I will have the sodium hydroxide in my pirate, and the a certain amount or a known amount of sulfuric acid will be in my measuring flask, and will just add some of this sodium hydroxide until I reach the end point. Let's look at this example. In a titration experiment, a student finds that 23.48 ml of sodium hydroxide solution are needed to neutralize 0.5 grams of sodium hydrogen phosphate. What is the concentration and molarity of the sodium hydroxide solution? If I know that the molar mass of sodium hydrogen phosphate is equal to 204.2 grams. So if I know now the molar mass of potassium hydrogen phosphate and I know the grams, I can find out the moles of the potassium hydrogen phosphate that involved in this reaction. So mole of potassium hydrogen phosphate would be equal to 0.5468 grams multiplied by, for each 1 mole of potassium hydrogen phosphate is equal to, contains 0.4.2 grams of potassium hydrogen phosphate. This would be equal to 2.678 multiplied by 10 to the power minus 3 moles. If I know that for each mole of potassium hydrogen phosphate is equivalent to the same 1 mole of sodium hydroxide, so if I have 2.678 multiplied by 10 to the power minus 3 moles of sodium hydrogen phosphate, this means it reacted with 2.678 multiplied by 10 to the power minus 3 moles sodium hydroxide. Now I know the number of moles of sodium hydroxide, and I know the volume of the sodium hydroxide. I can calculate the molarity. So the molarity of sodium hydroxide would be equal to the number of moles divided by the volume of sodium hydroxide in liter, because here is presented in ml. This means I have to multiply here by 1000 divided by 1 to be able to convert the ml into liter, and this would be equal to 0.1141 molar. So the concentration of hydrogen of sodium hydroxide in my sample is equal to 0.114 molar. By that we came to the end of our video. Till next video, thank you and goodbye.